This is the European Space Agency's headquarters in Paris, France. Within these walls, and the walls of many research facilities across Europe, researchers are working on one of their most ambitious projects yet. That is, to create a virtual planet Earth. And no, this is not Europe's answer to the metaverse. The reasons for this digital planet are actually to save the real one. The premise of this virtual planet is commonly referred to as a digital twin. A digital twin is a virtual representation of a physical object or system that can work in real time. It enables scientists and engineers to observe a system in precise detail and also see how it will react to different scenarios into the future. Doing this can be challenging or just impossible to do with the actual physical object or system you're interested in. Although the idea has been around for quite some time now, the first practical definition came from NASA in an attempt to improve simulations and monitoring of spacecraft in 2010. So, how is this now being used for the Earth, and how will it help save it? As you may have heard, population growth and human activity are putting pressures on our climate, stressing the world's ecosystem, depleting critical resources, and increasing pollution levels past what has been deemed safe. But in order to prevent these issues, we need to understand the effects of changes we make. This is where Earth's digital twin comes in. This twin represents a step change from current global scale simulations used for things like weather prediction. The proposed twin will combine simulations and real observed data to monitor and predict changes to our planet. This could be up to multiple decades into the future, and include the effects of future events from volcanic eruptions to changes in land use. A critical difference between this model and the previous ones is the detail. This digital twin will model the Earth in 1 km² sections, which is down from 81 km² sections previously. That relates to 510 million sections, or elements, up from 6 million. Because of this, it is possible to do much more detailed physical modelling, such as convection currents. These physics-based models use many equations for heat and fluid flow to predict what will happen in adjacent elements over time. So the more elements you have, the more accurate this can be. And where physical modelling is still not possible, machine learning will be used to approximate values. This, of course, comes at a cost, and the currency is computing power. Current simulations using the 1 km² elements have been run on the Oak Ridge Summit supercomputer, which is the second fastest computer in the world. For me, one of the most exciting parts about this is how it will be used to shape future climate strategies. Unfortunately, those currently making decisions on climate policy are not always the most informed. However, with the digital twin, policymakers will be able to see the effect of their plans and policies in real time, using familiar metrics. For example, a politician may be able to see the effects that phasing out fossil fuels in 10 versus 20 years' time will have on air pollution levels and global temperatures, or how coastal protection measures will hold up given different amounts of sea level rise. Currently, a number of different aspects of the digital twin are in the works. This first one is specifically a twin of Antarctica. By combining satellite observations, numerical simulations, and artificial intelligence, a team from the University of Edinburgh have built a twin of the Antarctic ice sheet system. This can now help track the whereabouts of meltwater on and under the ice sheet, and explore how fringing ice shelves could melt under different scenarios. While a team from the National Research Council in Italy have been focusing on hydrology. So far, they have been able to identify possible locations and times for landslides and flooding in the Powell River Basin in northern Italy. Other interesting projects within the Digital Earth mission include climate impact models, which are currently looking at droughts in Africa, the digital forest, which can help us understand the causes and effects of deforestation, and finally, the digital ocean, which is currently focused on heat waves and ice dynamics in the Mediterranean and Arctic seas, with the hopes of understanding how these will affect the vast ecosystem in our oceans. Thank you for watching. If you enjoyed, please leave a like and subscribe to the channel for more sustainable technology content.